Hello, we're here today to discover a new innovation in facade design. Today we are speaking of a new design method that considers climate resilience in facade design and in particular heat resilience. I'm here with my colleague Eugene Kim. We are both part of TU Delft and both part of a larger research project that is called MultiCare, which addresses multi-hazard and multi-scale resilience assessment in the urban environment. But here we're speaking about facades today. Eugene, what is your innovation about?
I'm specifically focusing on integrating multi-risk into facade design. And as a part of it, I'm developing this methodology, which is called thermal fragility curves for extreme heat events.
And how did this idea come about?
It started from identifying the research gap in this area. So when we talk about multi-hazard or multi-risk, it's mainly most of those methods are probabilistic based, but only in the heat part we are lacking this kind of integration. So the idea was, why not take the methodology that's been already established in other fields like seismic and then bring those methodology to the heat domain. So that was a bit of a background.
And I see here one example, for instance. Can you walk us through this graph?
So this thermal fragility curves shows at certain given heat intensity, what's the probability of exceeding certain safety thresholds. So this shows the likelihood in a probabilistic manner. And what's unique about this is that you can have this fragility curve for one facade component, and this is agnostic to the location that you're in, because you can find and walk through this chart.
Through the intensity, and then you get the probability.
Yeah.
So the TRL up to now, I guess, is between 3 and 5, because we are demonstrating it in a real environment soon. Now, what are the main barriers we are facing to accomplish a final fragility curve ready to go?
There are two main challenges. The one is that we need to translate the future climate scenarios into the weather files that we can actually use in practice. That's one. And another one is that when we are defining the thresholds, these thresholds are like safety indoor temperature thresholds. And we need a common agreement on where we set these thresholds for discomfort. Because this is something new, this research, and we need to have
this knowledge.
Yeah.
Oh, great.
The first application of these methods would be that it can easily be integrated with other probabilistic-based multi-hazard or multi-risk approach, so that all our methods can be way more robust in that way. So that's the most
great.
important application.
They will enable finally to integrate heat resilience in a multi-criteria design process, which is often the process we follow in facade design, but at the moment, without accounting for heat resilience. Thank you, Eugene. Thank you very much.